chemistry channel with Sarvat Ahmed. Be sure to like the video and subscribe it. Really helps the channel to grow. Today I will solve October-November 22 paper of chemistry 1-2. Let's start. Why is the first ionization energy of phosphorus greater than the first ionization energy of silicon? We know that across the period ionization energy is going to increased. So silicon is present in group 4. Silicon is present in group 4 and phosphorus is present in group 5. So why is the first ionization energy of phosphorus greater than the first ionization energy of silicon? So let's phosphorus. So this is the ionization energy trend. This is sodium. This is magnesium. This is sodium, magnesium, aluminium. Then it is going to increase over here for silicon, and this is phosphorus. Then again phosphorus, sulfur, and then generally going to increase. This is the trend of the phosphorus, sulfur, chlorine, and this is argon. So this is the general trend of ionization energy in the periodic table in period 3. Now phosphorus is greater than the first ionization. Yes, phosphorus is greater than first ionization energy of silicon because this is the electronic configuration of phosphorus: 1s2, 2s2, 2p6, 3s2, 3s2, 3p3. So this is 3p3. 3p3 phosphorus has half-filled orbital, and half-filled orbital is more stable than the partially filled, and silicon is like this. So this is partially filled orbital. So why is first ionization energy of phosphorus greater than the first ionization energy of silicon? This is half filled. Half filled is stable orbital. There is no pair repulsion. So that's why removing electron from this type of orbital is very difficult. High energy is required. So that's why phosphorus has greater. Now let's see the option. A phosphorus atom has one more proton in its nucleus. Yes, phosphorus has 15 electron while silicon has 14. So one more electron. So this should be correct. The atomic radius of phosphorus atom is greater. Now this is wrong because atomic radius is smaller. Across the period atomic radius is going to decrease. The outer electrons in phosphorus atom is more shielded. This again, this is wrong because outer electrons in phosphorus atom is more shielded. This is 3 electrons over here. Fourth row, the more electrons are there in silicon. There are outer electron is phosphorus because same across the period that shielding effect is constant. So this is also incorrect. The outer electrons in a phosphorus atom is paired. This is wrong because outer electrons are not paired. So this is unpaired electrons. 5 electrons and 1 pair, the outer electron in phosphorus, outer electron. So first option is correct. Sodium peroxide is used to absorb carbon dioxide from the atmosphere and releases oxygen in closed environments such as space capsules and submarines. Sodium oxide plus carbon dioxide to form sodium carbonate and oxygen. Which mass of sodium peroxide would be required to remove 2.94 dm cube of carbon dioxide from the atmosphere at room temperature pressure? Which mass of sodium peroxide? So first calculate the mole of carbon dioxide. Mole of carbon dioxide 2.4 dm cube divided by 24. The answer is 0.1 mole. Mole ratio Na2O2 ratio carbon dioxide 2:2, the same moles of sodium peroxide. Na2O2 is equal to 0.1 and mass of sodium peroxide is mole into mR. So mole is 0.1 into mR is sodium 23, Na2O2 23 into 246 plus 32. So this is equal to 7.8 gram. So this option is correct. Now next question is in which species are the number of protons, neutrons and electrons all different? In aluminium there are 14, 13 proton, 13 electron. Number of protons, neutrons and electrons all different, and 14 neutron. In B 1735, 17 proton, 18 electron and 18 neutron. Sulfur, this is also incorrect. Sulfur 32, 16 proton is 16, neutron 16 and 18 electron. This is wrong. D is 39, 19. Protons, neutrons and electrons all different. Proton 19, 19 proton, 18 electron and 20 neutron. So this must be correct. Now question number 4 is calcium oxide and magnesium sulfide react with acid. Calcium oxide react with hydrogen ion to form calcium ion plus water. Magnesium sulfide to form 2H positive to form magnesium 2 positive and magnesium ion and hydrogen sulfide. A mixture of these two compounds X react with exactly 0. X reacts exactly. Mixture of these compound X react exactly with 0.125. It means total moles of HCl is equal to 0.125. Now of hydrochloric acid, the amount of hydrogen sulfide formed is 0.025 mole. If amount of hydrogen sulfide is 0.20250, then what would be the mole of hydrogen ion which are used? So the mole of HCl H2S ratio 2H positive and 1:2, so the 0.025 ratio x, so it means 0.05 moles of HCl is used to form H2S. So the mole of H positive used is equal to 0.05. Now the moles left, sorry, you over here, moles of H positive left is equal to 0.125 minus 0.05, which is equal to 0.075. Now this moles react with calcium oxide, so CaO ratio H positive 1:2, 0.075 ratio x. So mole of CaO is equal to 0.0375, and mass of CaO is equal to 0.0375 multiplied by 40 plus 1 plus 16 mR of calcium oxide. This is equal to 2.1 gram. So answer is B. Next question is about 2 moles of vanadium VO2 ions react. VO2 positive react with 1 mole of zinc atom solid in the presence of H positive ion to form the products include zinc 2 positive and iron aqueous plus Y. Iron Y contains the vanadium. Only zinc and vanadium changes oxidation state. Over here water, if hydrogen ion is there, so place water over here. So we have to find out vanadium compound from the given options. So we know that zinc is going to oxidized. If zinc is oxidized, zinc to losing 2 electron. So the oxidation state of vanadium over here is +5, and 2 minus 2 is equal to -4. This is equal to +1. +5 minus 4 is equal to -1, so it is +1. Now as zinc losing 2 electrons, zinc is oxidized 2 electrons into 1. So it means if zinc losing 2 electrons and this difference is +1, the compounds the reductions, so if this is oxidation, the reduction VO2 plus H positive plus electron to form if it is plus 1 and the answer is plus 1. If this is plus 5 and minus 6, difference is plus 1. This is plus 3 and minus 2, and this is plus 4 and minus 2 electron. Minus 2, the difference is plus 2. So if zinc losing 2 electrons, so it should be 2 moles over here. So 2 electron over here and 2 moles over here. So if 1 mole losing 1 electron, if 1 mole of vanadium and 2 moles losing gains 2 electrons to form the compounds which have difference of plus 2, VO 2 plus water, 2, this is 4H. So the answer is 2 electrons are cancelled out. This is reduction. So the option is C is the best option. This is reduction, and this is equal to C. And if we balance this electron zinc, and over here BO 2 plus VO 2 plus, so this is so this is the this is option. So it is plus VO 2 plus, because VO 2 plus 2 Vx plus minus 2 is equal to plus 2. V is equal to plus 4, and over here plus 5 minus 4, x plus 2 minus 2 is equal to plus 1, and x minus 4 is equal to plus 1 plus 4. So this is plus 5, this is plus 5, and the difference is minus 1. Difference is 4 minus 1 electron. Over here difference is over here plus 4 and minus 2. Difference is plus 2. So C option is correct option. The compound potassium bismuth 5 KbIO3 is a powerful oxidizing agent. What is significance of the V? V is the oxidation number of KbIO3. This is the oxidation number of bismuth 5 plus 5. So it is the oxidation number of bismuth atom. A is correct option. Question number 7. Question number 7. Hydrogen peroxide decomposes slowly at 20 degrees centigrade to form water and oxygen. The reaction is faster when a catalyst is present. Which statement is correct? The catalyst alters the Boltzmann distribution so that the reactant molecules have more energy. Catalyst does not alter the Boltzmann distribution, so it is incorrect. The catalyst has no effect on the value of Kc. Yes, this must be correct because Kc is only temperature dependent. The catalyst increases the value of Kc. No, the catalyst provides a different reaction mechanism with a higher activation energy. The catalyst provides a different reaction mechanism with a higher activation energy. Lower activation energy, not higher. So this is also incorrect. A dimer Q is stable when solid, but dynamic equilibrium is set up in solution. A solution Q has an initial concentration 0.50 and this is 0. When equilibrium has been reached, the Q has fallen to 0.25. The changes in Q and R are plotted against time until equilibrium is reached. The value of Kc is then calculated. If the difference 0.25 is going to decrease, then this is 1:2, so this would be 0.50. So to calculate Kc is equal to 0.50 divided by 0.25. So this is equal to 1. So Kc would be 1. So this is incorrect. This might be correct. This might be correct. And this is also incorrect. Now graph the constant, which graph and value of Kc are correct. This is the R concentration over here is this, which is incorrect. So it is also incorrect. So over here concentration of R is 0.5, which is incorrect according to this value. So C option is correct option for this reaction. The reaction pathway for the forward reaction of a reversible reaction is shown. Which statement is correct? The activation energy of reverse reaction is plus 80. Reverse reaction, this is exothermic reaction. Forward reaction, if we plot reverse reaction, that will be endothermic. If we see that this is 30 plus 40 is in then 50 is the enthalpy change, and now over here 30 is more, activation energy is more, and this is enthalpy change. So activation energy, we can add up this if we use this side like this. So 30, this is activation energy, this will be activation energy, this will be activation energy, and that is 30 plus 50 is equal to 80. This option is correct. 30 is incorrect. Enthalpy change for the forward reaction is 30, so this is 50. The enthalpy change for the forward reaction is 50 kilojoule per mole, so this is also reaction, reversible reaction pathway for the forward. Which statement is correct? Enthalpy change for the forward reaction is 50, forward reaction is 50 kilojoule per mole. The enthalpy change for the reverse reaction is 30 kilojoule per mole. Which statement is correct? So for the reverse reaction, for the forward reaction. So for overall reaction, the enthalpy change, activation energy of reverse reaction is 80 kilojoule. The enthalpy change for the forward reaction is 50 kilojoule. So this is not for forward reaction, this is reversible reaction. So forward and backward reaction both has enthalpy change 50 reaction. So the enthalpy change for the reverse reaction is not 30 kilojoule, because reaction is like this when it is going forward as well as backward. So A option must be correct. The enthalpy change for the possible reactions W, X, Y, Z are shown. W is exothermic, this is endothermic, this is endothermic, this is exothermic. Which statement about the activation energy of these reactions is correct? X is greater activation energy, X is greater because X is endothermic, so X has greater activation energy than Y. Y is again endothermic, both have greater, X is greater than W, and X is greater than W. Yes, it is correct. And Z is greater than Y. Z is exothermic reaction, Z is exothermic reaction. Z is greater, no, Z is not greater, Z is lower activation energy, so it is incorrect. X is greater than W, this is correct. Y is greater than W, yes, Y is greater than, this is correct option. So B is correct answer. The Haber process is carried out with a nitrogen partial pressure of 50 kilopascal, a hydrogen partial pressure 150 kilopascal, a temperature of 400 degrees centigrade, and an iron catalyst. If all other conditions are kept the same, which change will result in a raised activation energy? Both the nitrogen and hydrogen partial pressures are changed to 100 kilopascal. 50 kilopascal, Haber process carried out with nitrogen partial pressure 50 kilo, hydrogen partial pressure 150 kilopascal. No, it is incorrect. The iron is removed. In all other conditions are kept the same, which change will result in a raised, because all other conditions should be will be same, so it is not correct answer. Raise will raise inactivation energy. The iron is removed, iron act as a catalyst, so by removing iron the activation energy is increased, so B option is correct. The nitrogen partial pressure is increased to 150 kilopascal, so all other conditions are same, the temperature is also not valid. The compound CH3 thrice NaCl3 has a simple molecular structure. Which statement about this compound is correct? Molecules attract each other by hydrogen bond. No, hydrogen bond is absent in this compound. This is the compound Cl, 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 and CH3N. This is nitrogen, has lone pair, and CH3, this is tertiary, so it formed dative bond with dative bonds with aluminium. So molecules attract, so no hydrogen bond is there. The aluminium atom has an intermolecule incomplete valence shell, so it has completed now after forming the dative bond, so it is also incorrect. The bonds around the aluminium atoms are planar, so this is tetrahedral structure, so this is not planar structure. The bonds around the aluminium atom are not planar, thus this is non-planar, because this structure is tetrahedral and tetrahedral geometry is not planar, so it is also incorrect. D option is correct. The molecules contain coordinate bonding. Over here coordinate bonding, so this option must be correct. The Vesper theory, next question 13. Vesper theory should be used in answering this question. The dot and cross diagram for an ozone molecule is shown. What is the predicted bond angle in this molecule? This is means so, and dative bond over here. What is the predicted bond angle in this molecule? We know that if geometry is 3 bond pair, this is lone pair, act as a density region, and 2 double bond also has 1 region according to Vesper theory, 1 density region. So this is basically planar structure. If for example 3 bond pair, trigonal structure, bond pair plus 0 lone pair, then bond angle will be 20. So if 2 bond pair plus 1 lone pair, the bond angle will be slightly less than 120. So 120 is not, 107 not. C is best option. Each of the substance shown in is gaseous. Which substance is most likely to show ideal behavior in the conditions shown? Ideal behavior, high temperature and low pressure. So in this case carbon dioxide 250 temperature and 1 mole per dm³. These two gases have high temperature and low pressure. This is 1 into 10 raised power to 6 and this is 1 into 10 raised power to 5. So HCl is a polar molecule, and polar molecule is does not show ideal behavior. So N2 is HCl is showing ideal behavior because temperature is too high and pressure is too low, but this is the best option should be nitrogen, because nitrogen is a non-polar molecule and temperature is very high and pressure is low, so that's why C must be best option. Which graph represents the variation of pressure P and volume V of a sample of an ideal gas at constant pressure? We know that PV is equal to nRT, where pressure is inversely proportional to volume of gas. So by increasing of pressure, volume is decreased, and by increasing pressure, volume is decreased, and by decreasing pressure, volume is increased. So PV, this is directly proportional, this is not, and this is also not correct graph according to PV. This is not like this. Volume is increased not like this by increasing pressure. So this must be, says pressure over here, by decreasing pressure volume is increased. So D option must be correct. Use relevant enthalpy changes from the table to answer this question. Which value can be calculated for the enthalpy change for the following reaction? We have H. So this is reactant side and this is product side, and we know that delta H is equal to energy absorbed minus energy released. So we have energy released. So there is no molecules, only carbon in gaseous state and hydrogen is in gaseous state. So energy absorbed is 0 minus. Now we need to know the bond energy is given over here, CC bond energy is given, but CH bond energy is absent. So in above equation, breaking of CH4, we have CH bond. So if we know that CH4, this is 4 CH bond. For breaking of 4 CH bond needs 1648. So 1 CH bond needs 1648 divided by 4, which is equal to minus 412, and this is breaking of this is minus 350. If we have 6 bonds over here, 1 2 3 4, so we use this energy for 6 CH we have 412 into 6, so this is equal to, and now we have CC bonds. CC bond is 350. Now by using this reaction like this, minus 350 plus minus 6 into 412, so it is delta H reaction is equal to minus 28 to 2. Next question, element X requires strong heating to react with oxygen. Element X reacts with chlorine to give covalently bonded chloride. What could be the identity of element X? Element X requires strong heating to react with oxygen. X reacts with chlorine to give covalently bonded. If covalent bonds are formed, covalent chlorides are formed, it means magnesium form ionic chloride, so it is incorrect. And sodium also form ionic. So now come to phosphorus. Phosphorus does not need strong heating. X reacts with chlorine to give covalently. Silicon require strong heating with oxygen because it is giant covalent structure. React to form X reacts requires strong heating with oxygen to form silica, which is giant structure. So D is the best option. And when it reacts with Cl2, it forms silicon 4 chloride, which is covalent molecules. Question number 18. Melting points of period 3 elements sodium to aluminum are shown. Which factors explains the increase in melting points from sodium to aluminum? Okay, the change in first ionization energy from sodium to aluminum, ionization energy does not depend melting point does not depend on the first ionization energy. The increase in electronegativity from sodium to aluminum, these are metals, so electronegativity, melting point does not depend on the electronegativity. The increase in the AR of the element from sodium to aluminum, so AR atomic mass does not depend the melting point. So increase in the number of outer electrons, so melting point depends on strength of metallic bond and strength of metallic bond is directly proportional to the number of valence shell electrons. More the valence shell electrons, stronger the metal is, and if stronger the metal is, has higher melting point. The increase in the number of outer electrons in each atom from sodium to aluminum. The increase of beryllium, calcium, magnesium and strontium all decompose in the same way when heated. When 2 gram of one of these anhydrous nitrate is decomposed, 1.32 gram of gas is produced. So this is very simple method to find out First write down the metal nitrate chemical equation of decomposition MO, and this all metals are group 2, NO2 plus oxygen, NO2, and this is 2 gram and 2 gram, loss in mass 1.32 gram. Now we have MR of nitrogen dioxide is 46, and because it is 2 moles, so plus half mole of oxygen 2 is equal to 6. So the total MR of the molar mass is 108. So if 2 gram releases 1.32 gram of mass, lost 1.32 gram mass, then what would be the loss in mass if 102 gram? What would be the magnesium nitrate, or sorry, metal nitrate is used if 108 gram of gas is produced. So this is gram of gas. So 102 nitrogen dioxide is gas, oxygen is gas. So when we add the MR of molar mass of these two gases, this is equal to 1028 gram. So what would be the mass of metal nitrate? So by using cross multiply, we have X is equal to 2 into 108 divided by 1.32. This is equal to 163.6. So this is the how to find out the MR of metal nitrate. This is MR of metal nitrate. So beryllium is not possible because 163 is larger mass. Now check out calcium nitrate. Calcium is 40.1 plus 2, 14 plus 48. This is equal to 163 point roundabout 1. This is equal to 40.1 plus 28 plus 48 into 2 is equal to 163.6 something. So this is the best option. In the diagram, each test tube WXYZ contained 25 cm cube of 0.1 mole per dm cube solution of salt. The test tube W and X 25 cm cube NaOH when react with barium chloride, barium hydroxide, it is aqueous, soluble hydroxide, this is also aqueous, NaCl, aqueous. MgCl2 plus sodium hydroxide, MgOH twice plus NaCl. So this is insoluble form precipitate, this is aqueous. Y is barium chloride plus sodium hydroxide, again barium hydroxide and NaCl, aqueous, both are aqueous, so no precipitates are formed. MgCl2 MgOH twice plus sorry, in this case barium sulfuric test Y and Z, magnesium sulfuric acid added, so BaCl2 plus sulfuric acid, it form barium sulfate, BaSO4 plus HCl. This is aqueous, this is precipitate solid, and in this case magnesium sulfate plus HCl, both are aqueous. In which test tube W and X does the liquid have the higher pH, and which of the test tube Y and Z has a greater mass of precipitate? This is aqueous, Y and Z. So in Y and Z no precipitate is formed. In Z there is no precipitate, in Y precipitates are formed. It means Y has greater precipitates, and in W aqueous solution of barium hydroxide is formed, which is alkaline solution, it has more higher pH, and in X magnesium hydroxide precipitate is formed. So and NaCl is the neutral solution, so the pH is not higher, it is 7 pH and over here 13 roundabout, because barium hydroxide is strong alkaline solution. So A option must be correct because higher pH in W and greater mass of precipitate in Y. So A is the best option. What is the oxidation state of chlorine containing species that kills bacteria in water? Cl2 plus water to form HClO plus HCl. So what is oxidation chlorine containing species? This is the chlorine containing species which kills the bacteria in drinking water, and its oxidation state is +1. B option is correct. Compound Q is white crystalline solid which dissolves easily in water. When concentrated sulfuric acid is added to a dry sample of Q, steamy white fumes are formed. When these white fumes are passed into the aqueous silver nitrate, white precipitate forms. Q is white crystalline solid which dissolves easily in water. When concentrated sulfuric acid is added to a dry sample of Q, white crystalline solid dissolves in water. AgCl is not dissolve in water, dissolve in water. This is insoluble in water, so D. Now we have answer in B and C. Now when concentrated sulfuric acid is added to a dry sample of Q, steamy white fumes is of HCl. So if HCl is formed, then it must be sodium chloride, because HBr, and what happened when it is further reacted, when these white fumes are passed into the aqueous silver nitrate, HCl, when AgNO3, white precipitate of AgCl form. So if HBr react with AgNO3, AgBr formed, which is creamy precipitate. So the precipitate is soluble in dilute ammonia. So AgCl is, when dissolves in ammonia, it is dilute ammonia, it will become aqueous. So if we add AgBr in dilute ammonia, it is AgBr solid. So AgBr dissolves in concentrated ammonia, so that's why option C is the best option. Question number 23. R is a solid. R fizzes when hydrochloric acid is added. R reacts with hot aqueous sodium hydroxide, giving off a gas which turns lime water. Reacts with hot aqueous sodium hydroxide, gives off a gas which turns damp red litmus paper blue. What is R is a solid. When hydrochloric acid, this is not correct formula, so this is incorrect. So NH ammonium carbonate can fizzes when react with HCl, and ammonium hydrogen carbonate also fizzes when react with hydrogen chloride. So R reacts with hot aqueous sodium hydroxide. Ammonium hydrogen carbonate, R is a solid. R reacts with hot sodium hydrogen hydroxide. CO2 plus NH4Cl, and R react with sodium hydroxide, hot aqueous sodium hydroxide. To form ammonia gas plus water plus Na2CO3. In this case, only one gas is produced, which turns damp. This is ammonia gas. So in this case, carbon dioxide is produced, and R when react with NaOH, hot aqueous sodium hydroxide. So hydrogen carbonate, this is an acid and this is alkali. So ammonia gas is produced, which turns red litmus paper blue, but this is ammonium ion. You know, ammonium CO3 2 minus. The formula is NH4 twice CO3. But in this case, ammonium ion positive, HCO3 negative. This formula is wrong, so it B option is correct option. Next question. Photochemical smog is a type of all pollution produced in urban areas by the effect of sunlight on substances released from vehicle exhaust. Which mixture of primary pollutants leads to the formation of photochemical smog? Carbon dioxide and water vapor. You know, photochemical smog is formed by the combination of unburnt hydro CXHY plus oxide of nitrogen to form photochemical smog. So photochemical smog must have oxide of nitrogen and burnt hydrocarbons. For carbon dioxide and water vapor incorrect. Carbon monoxide and unburnt hydrocarbon, nitrogen oxides and unburnt hydrocarbons. C option is correct, sulfur dioxide, and this is not correct. T is an element in period 3. The first ionization energy of T is lower than that of element with one less proton. The oxide of T does not react with water, insoluble in water. Aluminium oxide Al2O3, insoluble. SiO2, insoluble. Na2O, insoluble, soluble, and sulfur dioxide is soluble. So just, and now come to the aluminium and silicon. We know that this is lower than that of element with one less proton. And T is an element in period 3. Beryllium, magnesium, group 2, boron, aluminium, group 3. Then we have nitrogen and phosphorus, oxygen and sulfur. So these form these oxides. The oxides of these elements are soluble in water, so this is, we discard this. And now come to the boron and aluminium and beryllium and magnesium. This is period 3, and T is an element of period 3. First ionization energy of T is lower, so this is higher ionization energy, and this is lower ionization energy. So aluminium ionization energy, because sodium, this is magnesium, this is aluminium, and silicon has higher ionization energy, first ionization energy, and T element is lower than that of element with one less proton. So aluminium has one less proton than the magnesium, so aluminium is best option. And silicon is insoluble, oxide of silicon is insoluble in water, but silicon has higher ionization energy, and silicon has one more proton than aluminium, so that's why A option is correct. The structure of tartaric acid is shown. Which statement about tartaric acids are correct? A molecule of tartaric acid has more than one chiral center. Yes, this is correct. This is chiral center and this is chiral center. The molecular formula of tartaric acid is C4H4O6. C4 1 2 3 4, C4 1 2 3 4, 1 2 3 4, and over here H and over here H. So C4H6, 1 2 3 4 5 6 6. This is incorrect statement. One molecule of tartaric acid produces 4 hydrogen ions in aqueous solution. So 1 mole of tartaric acid producing 2 moles of hydrogen ion, not 4, 2 moles. One is from this side H positive and one from this side H positive. So one statement is only correct. So if one statement is correct, the option is D. Carboxylic acid P has no chain isomers. It reacts with an alcohol. No chain isomers. It reacts with alcohol Q that has only one positional isomers. What could be the ester? P has no chain isomers. So propanoic acid has no chain isomers. CH3, CH2, COOH. And it reacts with an alcohol Q that has only one positional. If we see butanol, CH3, CH2, CH2, CH2OH. So this is one butanol, CH3, CH2, CHOH and OH, CH3. So if we place OH over here, this is 2 butanol. So only one position isomer is there. So when they react with each other to form butyl propanoid, A must be correct option. Which pair includes a hydrocarbon without a chiral center? Includes a pair of hydrocarbon without a chiral. Which pair includes? So over here this is chiral center, and yes, this is chiral center. This is chiral center, CH3, and this is CH. Again, the two chiral center, this is incorrect. CH, CH2, CH3, and this is H, and over here CH3. So chiral center is there, and in this also 1, 2, 3, CH3, CH2, different groups. So this is chiral center. Both have chiral center. This is chiral CH3, and this is again two chiral center. No, this one chiral center. So both have chiral center. CH, this must be chiral center H, and this must be chiral center. In this case, this is not chiral center because this carbon has same group. Next is CH2, CH, CH3 and CH3. So this is again not chiral center, so this D option is correct. Which includes a hydro without a chiral center. So this pair has this has chiral, and this does not have chiral center. What is the major product formed when compound R is formed with an excess of HBr? When excess of HBr, it reacts with this. This is converted into, if major product is, this is replaced by Br, and in this Br. And this is breaking of double bond, and this is Br. So this must be a product. So Br. So this is not correct, because this is, if Br placed over here, then it must be, this is minor, She OH is so there are two types of reaction over here. One is nucleophilic substitution. OH is substituted by Br in the mechanism nucleophilic substitution, yeah, while HBr is added in alkene. This is addition reaction. This is electrophilic addition and this is nucleophilic substitution. Now this is correct. This is correct, but this is incorrect because Br is placed over there. Major product is formed. Question number 30. Cis butene reacts with cold dilute magnesium solution, manganate solution to give product X. Cis 2 butene. Cis butene. When react with cold dilute acidified, so it forms CH3 CHOH CHOH. When it reacts with hot, it forms 2 moles of CH3 CO2H because double bond is going to break over here and form 2 moles of carboxylic acid. Which row describing the reaction X and Y is correct? When sodium metal is added to the separate sample of X and Y. When sodium hydroxide solution is added to separate sample of X and Y. Sodium hydroxide does not react, no reaction with this compound. Plus sodium hydroxide, no reaction. But in case of this, when react with sodium hydroxide, it forms CH3 CO2 Na. It means Y react with sodium hydroxide, X does not react. Both X and Y will react. No, neither X when sodium metal is added. Yes, it is correct. Neither X nor Y. B. Both X and Y will react with sodium metal. Yes, only one of X and Y will react. 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 Yes, this option, only one of X and Y will react. So only Y is react. So this option is correct. So B option is correct. For which reaction will the major organic product have the lowest relative molecular mass? Bromomethane is heated under a flux CH3 CH2 Br plus sodium hydroxide to form CH3 CH2 Br plus is heated under reflux with an aqueous solution of sodium hydroxide, aqueous solution, to form CH3CH2OH. Bromoethane is heated and reflects with solution of sodium cyanide. So when it reacts with sodium cyanide, same, it forms CH3CH2CN. When it reacts with heated under reflux with aqueous solution of bromopropane, this is bromopropane, CH3 CHBr CH3 plus NaOH CH3 CHOH plus CH3, 2 bromopropane CH3 CHBr CH3 plus concentrated ethanolic sodium hydroxide. So this is elimination reaction. So it is formed CH3 CH double bond CH2. So the MR of this compound is 42, carbon 12 into 3 36 and 2 3 5 6 42. MR of this compound is ethanol 12 into 3, lowest MR we have to find out, 12 into 2 plus 16 plus hydrogen 6, 24 plus 16 plus 6, 24 and 16 30 and 30, 12 to the 24, 24 and 6, will the major organic product have the lowest relative molecular mass? Major organic product, yes, these two are